Hi everyone, welcome to today's Snack and Learn webinar on aviation integration. Just mentioning the housekeeping items before I hand it over to the presenter. The presentation slides are available to download in the handout box as a PDF for you to use, and also there will be time for question and answers. If you can please log your questions in the question box and we will address these questions at the end of the presentation. So I will hand it over to Aaron to start the presentation. Thank you.
All right, thank you, Sharon. Okay, so thank you everyone for being with me today. This is my third webinar of a series that our team has done. So today we'll be talking about aviation integration, paving the way for multimodal transportation. I am traveling, so hopefully my internet connection stays well. If we have any troubles, I'll turn off the camera for bandwidth or anything, but we're gonna dive in a little bit about myself. I was able to get started in the industry of aviation from a pretty young age, and I started to work for a company that was manufacturing parts to support vintage airplanes. And in addition to manufacturing parts, we also would do vintage aircraft restoration projects. So I was able to get a lot of hands-on experience from, again, from an early age. I worked for that company for 8 years and learned so much. But there came a day where I decided I didn't want to turn wrenches for the rest of my life. And so I went to college and got my bachelor's degree in aviation management, which opened a lot of doors. I went to work for the American Association of Airport Executives on their training team. And we were able to provide training solutions to airports across the United States. From there, I later got my master's in transportation systems from Cranfield University in the United Kingdom. And I then went into teaching, into academics, was teaching courses on uncrewed and crewed aviation. And then I found my way here to WSP. So I've been at WSP a little over 2 years now. And here I get to work on a variety of projects for drones and advanced air mobility, integration projects, and all things aerial innovation. So that's a little bit about me and a little bit about the aerial innovation team. We are housed within the U.S. Aviation Services Group here at WSP in the U.S. And so these graphics kind of demonstrate the various things that the aviation group does for airports across the country. But again, the aerial innovation team, we are focused on advanced air mobility, uncrewed aircraft systems, across a variety of things, whether that's communications or drone package delivery. And we are also just all things aerial innovation through research. So that kind of leads into various projects that we participate in. We have one going right now on extended realities, so augmented reality or virtual reality at airports, things like that. So a little bit more about what we've been up to in these webinars. Perhaps you've attended some of these. This is a list of the Snack and Learn webinar series that we did as a team throughout the year. So Jared did a lot on the electrification of airports and aviation in general, and bridging those gaps between what's really happening or going to happen versus perhaps fantasies or hype. Paul did a lot with drones and how drones are used across state transportation systems here in the United States and at airports. And then those last two, perhaps you joined me in a previous webinar. I did one with Brett where we talked about how drone package delivery could really help the rural areas in a regional setting for logistical systems, and help with things like food deserts or medical transportation, medical supply transportation, things like that. And then my most recent one, I talked about the scalability of advanced air mobility and kind of what has to happen there. We talked about some best practices and planning for AAM from a systematic standpoint. So in a way, these all kind of come together in today's presentation. So the agenda for today is to talk about advanced air mobility from that multimodal transportation perspective. And in order to do that, we need to know about some things that have happened in the past. And some of you that are joining today might be well aware of some of the things I'll talk about, but I'll discuss some historical challenges in this space. I'll talk about why advanced air mobility is perhaps different today and why it might be successful when it hasn't been in the past. I will talk about some use cases. And then I have 3 different projects that I'll talk about. They're all very different and unique, and yet they all relate to this topic of multimodal transportation. And we'll sum up with some key takeaways, and then as Sharon mentioned, we'll have time for questions. So going ahead and jumping into the historical side of things, we have some fun pictures here that I'll talk through over the next couple slides. I'll talk about the evolution of technology, helicopter airlines, and again, some of these historical challenges such as noise or safety, or the business viability of these operations. So starting with that photo on the top right, that's a black and white photo, not a drawing or anything. This is an actual photo of the Glenn Curtiss autoplane. Um, and this was not even 10 years after the Wright brothers flew the first aircraft. And this is an actual airplane that flew. It was never mass produced or anything, perhaps for obvious reasons. But we can see that this idea of trying to figure out how to combine the utility of a car and the utility of an airplane is not really a new idea. And that's something that the media kind of uses in different articles about flying cars of today, which I might discuss a little bit throughout today's presentation. But it's not a new idea to figure that out. We can see those by the bottom photos. If you fast forward, 30 years, this is in the 1950s. And this is the Taylor Aero car, which was actually certified by the Federal Aviation Administration here in the United States. So on the left, we see it flying through the air as an airplane. And on the right, we see it as a car. It could tow its wings and empennage behind it. And the technology is pretty cool because it could transition from airplane to car or car to airplane in about 5 minutes. And so again, this idea of integrating aviation or having aviation technologies be a part of an urban transportation system is not a new concept. We see that especially with helicopters. So the bottom left black and white photo is called the Flying Octopus. This was kind of the first attempt, one of the first attempts at a helicopter. And it's tethered there. You can see a person on board. This aircraft was not very maneuverable at all. That was one of the biggest challenges technology-wise to kind of figure out how to make helicopters stable and maneuverable. And so it took about 20 to 30 years to get to kind of the modern day helicopter, which came about at the tail end of World War II in the 1940s. On the right, you see a black and white photo of the Pan Am building in New York City. This Pan Am building had the heliport on top of it, and you can see an aircraft, a helicopter, coming in to land on top of that helipad there. So that leads us to a little bit about helicopter airline history. So in the United States in the 1950s, 60s, and 70s, the major cities throughout the US, places like New York or Chicago or Los Angeles, they all had pretty robust helicopter airline type operations. And what I mean by that is focusing in on this photo and the example of New York, you could book a flight out of JFK to wherever you needed to go, right? And you had an option to, through that airline, add on the flight from the Pan Am helipad to JFK. So it's kind of an add-on to your ticket. There was New York Airways had partnerships and things, and you could go to the Pan Am building to fly in a helicopter to JFK. These are still happening today, but on smaller scale. It was really kind of a robust scaled operation back in the 50s, 60s, 70s. But these various concerns noted here were a big deal. Noise of all the helicopters in the city, safety concerns. There were some pretty high profile accidents that took place, one in particular in the mid 1970s where a helicopter crashed as it was landing on top of the Pan Am building, and it killed people aboard the helicopter, as well as rained down debris onto the street and killed people on the street. So a lot of safety concerns. It was a very public accident that was discussed a lot. And then a lot of bankruptcy happening. There wasn't quite the economic viability that was needed for these operations. So these are some of the historical challenges that will lay the foundation for a few other things to discuss. So this leads to the discussion of why is advanced air mobility different? Maybe it is, maybe it isn't, but here's some key things to realize. We've had big advances in technology, obviously. One of the biggest examples that we can point to is distributed electric propulsion, or DEP. And on a really basic level, this is just what it sounds like, distributed propulsion across an airfoil, for example, a wing. And this has been studied for almost 2 decades now, and the electric side of it has really helped make this possible. So also battery technology is advancing, will continue to do so as far as the range of batteries and how light they might be to accomplish those ranges, the safety around them, things of that nature. Alternative fuels is something that we're always looking into as an aviation industry to become more efficient, more environmentally friendly, things of that nature. And then technology around autonomy and how autonomous things can be. So those are, from a technology standpoint, a big factor. Other factors is kind of the driving forces behind these movements can be things like a cleaner, more sustainable transportation from an environmental standpoint, but also from having a robust transportation standpoint for growth that we are seeing in urban centers. So that's a big aspect, especially for the eVTOL side, the aerial taxi side, which we'll come back to. And then there's tremendous financial backing that didn't perhaps exist in past historical attempts to build out urban air mobility. We could talk all day about failed attempts for urban air mobility, but today we see that there's tremendous financial backing. So a powerful statistic is at the end of September 2024, the eVTOL industry alone has had over $7 billion invested into it, and a total tentative order pipeline of over 20,000 aircraft. Now, I want to recognize that not all of those will come to fruition. There will be failed companies, bankruptcies, a consolidation that will likely take place. But again, it just shows the tremendous financial investment and support at this point. So keep some of those factors in mind as we continue through this discussion. So really quick, use cases, those technologies that I've discussed enable different types of aircraft that then enable different types of use cases. So this is a fun graphic from NASA that's been around for several years now. And as you start to look around the graphic, you can see the different types of use cases that can be enabled, whether that's small drone package delivery or urban operations or a regional operational model, helping with all sorts of use cases, like in the background there, wildfire observation, excuse me. As firefighters fight those wildfires, what kind of data can be collected with drones to help provide them information to make data-driven decisions. So all sorts of fun things can take place and are taking place across many of these use cases. So I always use advanced air mobility as an umbrella term. That's how it was meant to be when NASA came out with that term in 2020. And so this is really inclusive of those technologies and these various use cases. So here are a sampling of photos of different companies, of different aircraft. And as we think about integrating aviation into transportation or logistical systems, we really need to think holistically. And how can these technologies or aircraft help address problems that we're having, whether that's food deserts or even just the cost of food in general? How can we have a more efficient delivery system to hopefully lower those costs, for example? So whether that's smaller drones like you see there, or on the left, the Mighty Fly, or on the right, the Pika drone there. These are larger aircraft that can deliver larger or heavier payloads across longer distances, things of that nature. Or it's also use cases like electric aircraft for flight training to lower the cost of that, or on a regional component with the Aviation Alice is an example on the far right, or that top right is a proven aircraft airframe, a Cessna Caravan that is fully autonomous, and what autonomy can do for various use cases. So these are all things to really be considered. The one that I'll kind of focus in on a little bit more as we continue the discussion is eVTOLs, or aerial taxis. And this is what usually gets a lot of the media attention. So aircraft like the Archer, the Joby, or the Beta, these are perhaps three leading eVTOL manufacturing companies that, again, get a lot of attention. They're further along in the certification processes with the FAA, things of that nature. But this is, again, just a sampling of many companies that have various designs in different various stages of research and development or the certification process, things of that nature. So diving into our projects, again, as I said at the beginning, I'm going to talk about 3 different projects. They're all quite different, but they all have this similar thread that I hope I can pull through as we talk about multimodal transportation. So the first one I want to talk about is ACRP Research Report 275. So for this global audience that we have today, ACRP is the Airport Cooperative Research Program, It's one of multiple research programs that are housed within the National Academies of Sciences, Engineering, and Medicine here in the United States. And they fund cutting edge research projects that look at emerging technologies across transportation and often publish guidance manuals, the first of their kind to guide what that implementation might look like. So this was a unique report in the sense that it was a joint report across multiple of those research programs for transit, aviation, and on the highway side. And so together they looked at what does transportation look like in perhaps 10, 20, or 50 years from now? And it's really hard to predict those types of things. So this really focused in on creating a framework for folks to design. It's focused on planning and design of intermodal passenger facilities in an era where there's so much changing, right? Those technology advancements we're seeing, the way people travel, where people are choosing to live, so many different factors play into this accelerated change we see. But this report really outlines kind of a framework of how to stay flexible and what to account for. And it considers all modes of transportation for air, rail, bus, ferry, and other modes of transportation. So things like micromobility that I don't have on here. And WSP participated in this project. We provided various sections, but our team in particular provided the section on advanced air mobility in this report and what should be accounted for, what potential use cases to evaluate, and how those could be included when planning for an intermodal facility. So this is a public-facing report available to anyone and everyone. If you just Google the title of the report or ACRP Research Report 275, then you can get the public-facing link to download the report. So shifting to a different type of project completely, our team is involved with the Michigan Department of Transportation to test an unmanned aircraft systems communication mesh network. And this is a really exciting one. I'm going to kind of break down kind of the goals of the project and what this is about and what it could lead to. So the project objective is really just to test the feasibility of using cooperative intelligent transportation systems technology for communicating not only air to air, but air to ground. And there's this one is a big multimodal concept or component, because we have technologies where we can have, vehicle to vehicle communication, vehicle to infrastructure. More is happening with vehicle to pedestrian across this network that can be built out. But how do we add that aviation component, that air component, so that we can have a seamless travel experience across all modes of transportation is really the goal. And so while this is kind of initial testing, this project in particular with the Michigan DOT is to test that wireless technology specifically to perform radio frequency congestion and communications interference evaluations, coverage, reliability, things of that nature. It's really going to help MDOT support their ongoing deployment of beyond visual line of sight operations with drones. But really, MDOT has this vision to go beyond this. While this is initial testing, it can lay the foundation for that potential orchestration that can happen at the transportation hubs of the future. So really coordinating air and ground vehicles at those multimodal transportation hubs. You can think of it, if a train is arriving, the light rail is arriving with 50 people or 100 people to a transportation hub, and they're getting off at that stop, what transportation options do they have? Whether it's ride share, micromobility, or in this case, an aerial taxi might be an option if there's a vertiport as part of that transportation hub. So how can we really communicate and orchestrate a seamless travel experience across the travel ribbon to have a more efficient and robust transportation system? Again, the technologies are there. It's exciting to think about what that could look like, 10, 20, 30 years down the road. And those are the types of things we want to work together to figure out across the different modes of transportation. And so the last project I want to highlight is one that is doing a really good job of doing just that, of communicating across silos, right? So in the transportation industry, people become kind of an expert in their thing, and they just focus on that one thing. But an opportunity that advanced air mobility in general kind of presents is this opportunity to start really working together. And I know collaboration is kind of a buzzword, but to really truly collaborate across different transportation modes. So Utah is doing a really good job of this. I reside in Utah. and participate in a project with this. So Utah is coordinating effort to develop a statewide transportation electrification plan. They're doing this through various efforts. We have there's 9 subcommittees under the Utah Electrification Steering Committee, and our team is participating on the Aviation Electrification Subcommittee. So really breaking out of those um, transportation mode silos by, yes, our subcommittee and group is looking at the electrification of airports, but it's through the lens and opportunity of how do airports become transportation hubs. And an example of, if we're going to electrify the airport, bring more electrical infrastructure there, for charging of aircraft, how will that also serve bus fleets or cars, things of that nature? So again, they're doing a great job at that, and we're enjoying participating in those efforts. So again, those were 3 kind of different projects, but all kind of focus in on advancing the multimodal transportation hubs of the future and how aviation can fit into that. So hopefully some takeaways you've had today is advanced air mobility really is inclusive of various technologies and use cases. And all of those really should be considered when we're going to be talking about planning, logistics systems, cargo systems, transportation systems, and really need to break out of those silos to figure it out together. To how can aviation augment existing systems, not to come in and replace anything, but really to work together to serve humans. So that last point is really big for me personally. And why I love working in this space is at the end of the day, we want to figure out how to better the lives of people so that people can choose to live where they want to live, that they can have access to healthcare and food, things that they need. So how can these technologies really help support that? And not just for a select few, but for all people is really the goal. So with that, if you want to learn more about this topic, I mentioned this in my previous webinar, and perhaps you've seen this, but this white paper really focuses in on the scaling of advanced air mobility and how we can do that through vertiport automation systems. And there's a lot in the white paper from the multimodal transportation lens. So if you want to learn more, you can check out this white paper we recently published. Sharon will be including it in the handouts and in the email that you get following this. So with that, we will now take some time for questions.
Thanks, Aaron. Fantastic presentation and great examples. Thank you. Just mentioning again the housekeeping items, in the handout box in the control panel, you can find the presentation slide to download as a PDF, and also please continue to log your questions in the question box. I will start with the first question about drones. How do you think drones will contribute to the possibilities and concerns of expanding aviation transportation?
Okay, thank you. So yeah, that sounds kind of like a 2-part question. How can drones, what opportunities are there, but also concerns? So, I mentioned some of them throughout this presentation. I had the previous webinar with Brett about how drones can really help with, package delivery, cargo delivery, and the different things that could facilitate. So those are some opportunities, but let me focus in on the second part of your question of there are a lot of concerns. And with drones in particular, we see concerns around privacy, security, that drone won't be used for any malintent from a cybersecurity standpoint. And so the public has concerns a lot about the privacy, security, safety. They don't want it falling out of the sky onto their kid or anything. So I think those are the leading concerns to your question, and I think the way we address those is a lot of public outreach and truly listening to those concerns from the public and engaging with those in a meaningful way, talking to them about the technology that exists to address some of those concerns. So those are some of my thoughts to that question in particular.
Thank you. The next question is about area separation with uncrewed aircraft system or autonomous aircraft, for example, air taxis. How is area separation guaranteed?
Okay, yeah, so good question. Um, so I'll focus here on the United States, just because that's where I reside, and I'm not sure where the question may have come from, but here in the United States, the FAA recently published last summer the Innovate 28 plan, which kind of lays out their roadmap for how advanced air mobility aircraft will integrate into the national airspace system here in the United States. And really, it's to your question, it's going to be guaranteed by using traditional and historically proven aviation system here. So whether that's through traditional air traffic control and things of that nature. But I think what you're kind of teasing out is what does it look like beyond that? And we know that to really scale up advanced air mobility use cases, we will need a robust UTM, so unmanned traffic management systems. And the FAA also has multiple documents published on that. Our recent white paper talks a lot about, vertiport automation system and that how that fits into a UTM. But there's not, I mean, we could have a full day webinar about UTM and what that could look like. How are we going to guarantee that air separation that you're referencing? And there's a lot to be figured out, right? There's technology that's advancing. One of the biggest obstacles that comes up with that is how to integrate that new technology into these legacy systems I was talking about. And so that's something that's going to need to really get figured out, and it'll take time to do so. And so that's basically what the FAA is trying to say is we're going to initially integrate these in our current system and how we operate and work, while also developing systems that can scale the technology. So.
Thank you. A lot of questions are coming through. Next question is, how far off do you believe we are from deployment of urban air mobility?
So urban air mobility, you chose to use that term, so I'll follow your thread there. Urban air mobility, so let's perhaps think aerial taxis, a robust aviation transportation system in an urban transportation, from an urban transportation lens. I think as far as deployment, I think we'll see that in the next few years, right? The biggest thing is getting through certification. So I've been in the space long enough to see that aircraft manufacturers continually kind of put off those dates. It's been promised a long time now. So hopefully they're saying next year, right, in 2025, that they'll get through that certification process. The FAA recently released some big rulemaking that answered a lot of questions about pilot training and various things. So once we get through that process, I think we'll start to see the deployment. We'll see it roll out. But as far as kind of predicting scaling those and making it a robust system, I'm personally pretty conservative on my timelines. So those are some initial thoughts. I think we'll see the deployment here in the next few years, and there's a lot of things that have to come together to scale that beyond it. So.
Fantastic, thank you. We have a lot of questions coming through, but we will need to take the last one just to be on time.
Okay.
There's a question from California about scaling EVO. I will read it. What challenges do you foresee in scaling EVO operations from a few initial vehicles to a fully integrated network that can handle a significant portion of urban travel?
Okay, great. Yeah, great question. It builds off of what I was saying on the previous question. California, a lot of eVTOL manufacturers or operators are big on California, right? And they kind of like to focus in on the traffic congestion there, and Los Angeles, right, is a big one that everyone wants to get into. So your question specifically though is what challenges do I foresee in really scaling that up? It's things like I was just talking about, right? The UTM system that's going to have to come into place. It's one thing to integrate a few kind of one-off examples or use cases or business cases, but to really scale that up, and that brings in the question of business viability, right? One of the historical problems I talked about at the very beginning of that economic viability of the business model, that in and of itself is a challenge. You have to scale these things up to become economically viable. So things like economic viability, UTM, public acceptance. And I don't like the word public, that phrase public acceptance, because we don't want to force acceptance onto any communities. So really public engagement, right? And how to engage with those communities to, again, in a meaningful way, hear their concerns and work together to address those concerns. So I'm sure there's a lot more, but those are kind of three buckets of challenges that I see for really scaling it up in cities.
Fantastic. Thank you, Aaron. Fantastic presentation. It was great to have you again presenting for the third time this year. Thank you so much for all your efforts. And thank you everyone for your questions. Fantastic questions. All additional questions that were unanswered will be answered directly by Aaron. So feel free also to reach out to him via the contact details that are shown on the screen. And that's it. We will wrap up the session now. Thank you so much. Have a wonderful day.
Thank you, everyone.